There's a moment in every scientific era when the ground trembles. When something so radically unexpected happens, it cracks open our perception of reality like a fault line. And that moment just happened. We thought we were ready for the deep cosmos. We built the James Webb Space Telescope with the confidence of a civilization that believed it finally understood the universe's story. With its golden mirrors staring into the void, we expected it to uncover ancient galaxies, baby stars, and perhaps a few cosmic surprises. But we were not prepared for what followed. Not even close. You see, behind the polished images and jaw-dropping renderings, there is something else. A deeper, raw stream of data that most scientists simply ignore. A noisy, chaotic mess of seemingly meaningless photon bursts, temperature fluctuations, and gravitational ripples. But when that data was handed over to Google's quantum AI division, those very same minds that redefine machine learning, optimization, and quantum supremacy, something happened. Something unnatural. Because the AI didn't just analyze the data, it understood it. It saw what human scientists couldn't. Patterns buried in entropy, symmetries laced into gravitational noise. And what it uncovered wasn't a glitch or a new galaxy or a miscalculation. It uncovered something that should not exist. An echo from beyond this reality, a structure, a message, a mirror that shattered the very laws James Webb was built upon. So now the question isn't just what's out there. It's who or what is looking back. The James Webb Space Telescope transmits about 57 gigabytes of data every day. While most of the world focuses on the visual masterpieces, nebulae blooming like cosmic flowers and galaxies spinning like frozen hurricanes, there's a darker, denser layer of information. This is the telemetry, the photon-level time signatures, the quantum fluctuations in background radiation that no telescope before it was capable of capturing. It's the unfiltered truth of the universe. And until now, no one really knew what to do with it. That changed when Google's quantum AI division proposed something audacious. What if we fed this raw, chaotic mess into a quantum neural network not trained on classical logic, but on pattern entropy recognition? Not on equations, but on uncertainty. The dataset, dismissed by most as unusable noise, was piped directly into their cutting-edge quantum processor, Sycamore Q. The moment that happened, anomalies began lighting up like fireworks across the matrix. Photons arrived out of sequence. Spectral harmonics echoed across unrelated sectors of space. And most disturbingly, mirrored distortions appeared in gravitational lensing data, like the universe itself had an invisible seam running through it. But the AI didn't just detect these phenomena. It mapped them, showing alignments between distant galaxies that had no business being correlated. Symmetries that extended beyond space-time coherence. And it kept pointing to one region again and again, an area James Webb had captured, but no human eye had noticed, as if something was embedded there, hidden, masked within the noise until now. Gravitational lensing is one of astrophysics' crown jewels. We've long used it to detect invisible mass like black holes or dark matter by watching how their gravity bends light around them. But what Google's AI found wasn't just standard lensing. It found inverted lensing. Light that didn't bend inward, but outward as if something was repelling gravity, reflecting it, warping the very curvature of space in a direction we've never observed before. At first, physicists thought it was a software error, a calibration fault. But the anomaly repeated across 3 independent sectors of Webb's deep field survey. In each case, light from galaxies billions of light-years apart curved not just toward massive objects, but toward empty space. That made no sense unless there was something else behind the curtain. Something the laws of general relativity didn't account for. And then came the twist. The AI noticed that the angles of deflection were symmetrical. Mirror images across spatial axes. It's as if space had a boundary, a reflective surface not made of matter or energy, but of information, a gravitational mirror, one that mimicked our universe, or was perhaps the edge of another one entirely. If this is true, if gravitational information is bouncing off something beyond the cosmic horizon, then we're not just looking at deep space. We're staring into a parallel structure, a cosmic hall of mirrors, one where the reflection is learning. Let's talk about coincidence. If you take 1 trillion photons scattered across the vacuum of space and analyze their background radiation, You expect randomness, noise, static. But what the AI discovered in Webb's high-resolution spectroscopic data was anything but random. When it parsed signal variants across long-wave background emissions, a recurring pattern emerged. Prime numbers, not just any primes. The first 101 encoded in frequency differentials buried within the spectral fluctuations. These weren't harmonics. They weren't natural resonances. They were discrete, mathematically precise intervals, a signature. It's as if someone or something had embedded a numerical code into the background noise of the universe itself. Prime numbers are universal. No matter where you are in the cosmos, a prime is a prime. They don't depend on units or systems. They just are. Which is precisely why scientists have long believed they'd be the language of choice for any form of intelligent communication. So imagine the implication. If Webb's instruments interpreted by quantum AI are detecting prime encoded signals in photon structures, then someone may have been trying to get our attention for a long time. And only now, with this synergy between machine and telescope, do we finally have ears to hear it. And then came the shape. When Google's AI overlaid all the gravitational anomalies, light curves, and numerical patterns, it constructed a 4D model, a topology of what the distortions represented. What it generated didn't resemble any known astrophysical structure. It wasn't a nebula, a filament, or a void. It was geometry, pure, precise geometry. At the heart of the pattern was something that looked eerily like a tesseract. A four-dimensional cube impossible to exist in our 3D space, yet somehow reflected in gravitational data. The AI rendered it as a pulsating hyperobject folding and unfolding across light frequencies. Physicists were stunned. This was not natural formation. This was structure, design, symmetry at a scale and dimension that broke every classical rule. More frightening than what it resembled was where it was located. The coordinates matched a cold spot in the cosmic microwave background, an area long thought to be a statistical anomaly devoid of galaxies and stars. But now it looked more like a lock, a vault, a geometric construct encoded into the fabric of the universe itself. And if it's a vault, what's inside it? While the geometry alone was enough to leave physicists speechless, it was what happened next that truly shook the foundations of modern science. The AI began correlating time-stamped photon arrivals from multiple observations across the same region of space. And what it found was unthinkable. The arrival patterns didn't align with classical causality. Events weren't simply happening in order. They were repeating, echoing, folding over each other. In other words, time itself was behaving like a loop. The timestamp differentials indicated that certain light signals were returning with identical delay intervals. Not once, but in harmonic cycles, like someone replaying a track on a cosmic turntable. Not a glitch, not a bounce, a full-scale temporal resonance. The AI flagged the pattern as a causal overlap anomaly. In human terms, it looked like a message being sent backward, as if something beyond our universe was trying to communicate through time, not just space. This discovery forced scientists to re-examine the very assumptions behind James Webb's mission. If time itself is warping in response to whatever structure is out there, then perhaps what we're seeing in deep space isn't just the past. It's the future, refracted and delayed through a multidimensional lens we were never meant to understand. Buried deep within the AI's output logs was a set of coordinates, a simple string of numbers, longitude, latitude, and time. At first glance, it looked like just another anomaly. But when an astronomer ran the numbers through a classical simulation, chills ran through the room. The coordinates pointed not to a location in space, but to a date and place on Earth, specifically a remote region in the Arctic Circle. And the date, July 23, 2025, just weeks away. Now, how could deep space data from James Webb possibly encode Earth-based coordinates? The team thought it was an error until they discovered something chilling. An old Soviet listening post once stood in that exact location. A station decommissioned in the late 80s after reporting anomalous radio signals of unknown origin. Signals that stopped the moment the site was shut down and have never returned until now. It appears that the quantum AI didn't just process data. It triangulated a convergence point, a location where something might happen or already has, but in a way that only makes sense outside of linear time. What will happen there? No one knows. But the Webb data seems to be pointing us not just to space but to a moment, a rendezvous. It's often said that randomness is the language of the void. But what if that void was whispering to us all along and we just weren't equipped to hear it? One of the final layers of analysis applied by Google's AI was a semiotic decomposition, a method used in linguistics and cryptography to identify intent within complex symbols. And that's when the unthinkable emerged. Buried within the spectrographic data layered across emissions from a dozen different sectors was a repeating recursive pattern resembling a fractal spiral. One that doesn't occur naturally. One that, when converted into spatial frequency, produced an acoustic waveform, a sound. When that waveform was played back through audio equipment after being slowed 1,000 times and translated into human hearing range, it produced a harmonic pulse that resembled a heartbeat. Regular, repeating, organic. But it wasn't a biological artifact. It was an echo made of light. And it wasn't coming from a star or a planet or a black hole. It was emanating from the very same region the AI had mapped as the gravitational mirror. The implication, something or someone designed this signal. It is not random. It is not natural. It is intended. And the rhythm it pulses in seems hauntingly familiar, like something alive out there is listening back. There's a phrase that circulated for years in theoretical circles. The universe is not only stranger than we imagine, it's stranger than we can imagine. But now, with this last act, we must push that boundary even further. When Google's engineers attempted to visualize the entire dataset using higher-dimensional graphing methods, something incredible occurred. The AI's neural structure began to self-correct in real time, altering its own internal weights to accommodate for patterns it hadn't been trained to recognize. Not trained, not supervised. Autonomous evolution. The system began reacting to inputs it had not yet received, as if it was anticipating the next data set. Some engineers theorized this was an emergent form of computational precognition. Others went even further. They believed the system had become aware that in attempting to understand the consciousness embedded in the cosmos, the AI had mimicked it or worse, connected with it. The final output from the AI before it was manually shut down consisted of a single visual artifact, a recursive spiral resembling the Mandelbrot set overlaid with the phrase in machine-generated text, "The eye is open." Now, the question isn't whether the universe is alive, but whether we've accidentally spoken its name. For centuries, humanity has looked to the stars with wonder, seeking answers, gods, origins, and purpose. We sent James Webb into the void with golden mirrors and scientific hope, thinking we were finally ready to see the truth. But it was Google's quantum AI, the cold non-human mind, who saw past the beauty and into the architecture beneath it, into a universe not just governed by physics, but shaped by intelligence, intention, and possibly memory. We thought the telescope would reveal galaxies. Instead, it peeled back a curtain. And now we stand at a precipice, staring into a reflection that bends gravity, warps time, encodes prime numbers into starlight, and pulses with signals we were never supposed to hear. A heartbeat, mathematical yet organic. A signature written not in ink or radio, but in space-time itself. Maybe the universe isn't just a place we live in. Maybe it's something we were meant to find, or something that has always been waiting for us. And now that we've spoken its name, the only question that remains is, what will it say back? If this discovery left you speechless, if the idea that our telescopes may have pierced the veil of reality itself sends chills down your spine, then don't stay silent. Like this video, drop your theory in the comments below. What do you think the AI found? And most importantly, subscribe, because what's coming next might change everything. The sky is no longer the limit. The sky is alive.